Hey Internet, what's going on? So today I want to talk to you about how to pick the right AI model for every coding task. With new models dropping every week, even people like me that spend time researching this daily can easily get overwhelmed by the plethora of AI models to choose from. One clear example of this is the dreaded dropdown for models. You see this in ChatGPT, Claude, Gemini, etc. And this dropdown stops many regular AI users from making use of these tools in an effective way. So I use a simple framework day in and day out that segments these models into two buckets. And I use this framework to pick the right model for the right coding job. So, with that being said, let's get into it. Alrighty. So, as always, we have our beautiful photo from the OpenAI gods. So here we have a poor fellow inside of a grocery store. So if you live inside of any capitalistic economy, um, you know that when you go to a grocery store, there tends to be a lot of options. So there's a lot of toothpastes, milks, etc. And this is a good problem to have, don't get me wrong, but it's also overwhelming. And you can swap all of these items here for models. So we have all these models that are different options you have to choose from, and it's overwhelming because you don't necessarily know which one to choose from for what reason. Now, to make this overwhelm more specific, I wanted to give a kind of an intro to model overwhelm and how it actually manifests in certain tools. All right, so we have OpenAI here as our first use case. And OpenAI has 1, 2, 3, 4, 5, 6 models. But the cool thing about OpenAI is they have certain descriptions here that give us more context to what each model represents. And that's useful. That gives us some context as to which one we should use for what purpose. The issue here is these sub-descriptions are a bit too vague. And for us to know exactly what model is relevant for our specific use case, the description would have to be massive. So this is useful, but it's not perfect. Now let's go to Cursor. So Cursor tries to be agnostic about the models they represent, which means they're going to have tons and tons of options. And I spelled Cursor wrong. So that is how much I use it. JK. All right, Cursor. So Cursor has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 models that are just default, mind you. So these are the default models that are shown. And you can even add custom models to this to bring your own your own API key. And you bring your own API key. You can then add additional models and name them as you please. So 14, I don't know about you, is a lot of models to choose from to know which model is most suitable for what use case, specifically in the context of code. Now we have Anthropic's Claude. So this one isn't as bad. So what do they have? They have 4, which isn't too overwhelming. I appreciate that. Thank you, Claude. Then we have Gemini from Google. They have it's deceiving because you're like, oh, they only have 2. That's so awesome. Don't believe it. Don't believe it because this is just the first tab. So this is the tab for 2.5. So this is 2.5 Pro and Flash. But then we have 2.0, 1.5, Gemma, and other. So in total, I think they had like 16 to like 18 models available. That again, is way too many options to know exactly which model is suitable for what use case. Now these are just use cases for UI. But let's look at how people compare these models. So this is just one of many different charts that you can look at to show you which models are most suitable for what use cases based off of different variables that people weigh for models, such as intelligence, context window length, price, etc. And here we're just seeing models that are SOTA. So these are state-of-the-art models. Not all models, just state-of-the-art. So I think this is like 30 of maybe 107, I think they had. There's 177. So it's some massive number of models they had available to then filter onto this. So just showing you there's tons and tons of models, probably too many. Now, to make the problem even worse, is oftentimes the way that we weight models is based on benchmarks. So how smart is it based off of code and math and whatever else? And there's 2 issues with benchmarks. One is one that's been known for a while, and we'll get to this actually in a second. One of the issues with benchmarks in the past is that benchmarks they optimize for a very specific type of problem, and they get really good at that. And that's useful, and it's a good approximation to understand how good something could be. But when we think about the approximation, very rarely does it map to our use cases. So oftentimes people say, oh, this model is great for coding, but it doesn't work for my use case for building my specific app. Instead, I find this other model is more useful. So it's important for us to kind of figure out which models are useful for our use cases based off of practice and not strictly benchmarks. In addition to that, another recent realization that people have been talking about is this new paper that was published that highlighted the fact that many of the commercial models, the ones that are not strictly just private, but Meta, the open source variants as well, is they've been gaming the leaderboards and making their models rise to the top much faster based off of some hokey pokiness. I won't go into the details here, but you can read this paper if you're interested. So we have benchmarks that are kind of deceiving. We have too many models to choose from, and the options and the drop downs are pretty overwhelming, especially for people that are looking at it day to day, but also even more for people that aren't looking at day to day. They just want to use these tools for certain use cases. So that's the overwhelm problem. Let's get into the lens that I use to specify here which ones to use. So I break this into two segments. We have planning and execution. Planning are the really smart models. So these are the brains of the operation. And planning is mainly used for reasoning through what our plan should be. And once that plan has been specified and written out by these smart models, they then pass these documents over to our executors. And our executors have to be good at two things. The first is calling tools effectively, and the second is executing on those instructions. So being very good instruction followers. Instructions. We'll start with planning. So these models are the ones that I use today. Now, that will change probably next week, next month, and 6 months. So it's important to think about this in the framework context, not the specific models I'm referencing. But with that being said, for today, I use 2.5 Pro probably most frequently for planning today. That will likely change over time, but I use this most frequently as of right now because its output length for tokens is a lot longer than others, meaning that it can spit out more content that gives us more detail. It's more thorough and methodical in what it provides. So I can then feed that off to another model to then follow those specific instructions. In addition to that, I use O3 quite often for other use cases. So this is specifically in relation to code. But I use O3 as my number one model. So this is my number one for some use cases. This is my number one for others. So this is code, and this is probably research. I use it a lot for research. I use this, what was the other one? So research, probably different types of strategic planning outside of code, and a variety of other use cases. I use it all the time. And then down here, we have O4 Mini High, which is not the smartest model, but it's a fast smart model. And that'll come into play later. We'll talk about interviews and how I use AI to interview me to get better documents. So that's the planning side. On the execution side, like I said, we need to be good at tools. We need to be good at following instructions. Of these different models listed here, for coding specifically, I often find myself using GPT 4.1 the most because it's probably the strongest when it comes to tool calling and instruction following. Secondarily, I use 3.5 Sonnet the most because it's it's good at tools and instructions. And then I will use 3.7 Thinking sometimes, but usually I only use 3.7 Thinking for gnarly bugs, so bugs that are pretty radical. Reason being is that 3.7 Thinking can sometimes go off the rails. It gets very opinionated and falls down in different loopholes and gets lost in these little tunnels, and it can't get itself out. So that's not always the greatest, and I use it, but I don't use it too much. And then I use 2.5 Pro. Again, for this is usually big bugs or maybe even sometimes larger functions we have to write out, where I'm afraid that the others will kind of run out of juice mid kind of generation of the code. So that's the execution side. That's kind of how I think about the models right now in that framework. And I wanted to give you some examples of how I apply this framework. So in our examples, we have a small example for a small use case. We have a mid-sized example. And then over here, we have a large example. So for the small example, this happened recently. So this is probably a few days ago. I was working with one of my clients. And the client was working on a presentation. And the presentation, they needed a series of really cool visuals to show data. Now, oftentimes when people think about presentations, they default to image gen from GPT-4o, which is a great tool for diagrams and charts and all that stuff. I agree. But sometimes if you have too much data, it can get too complex for that model. So it's best to get advice from other AIs to figure out how to do this effectively. And that's exactly what we did here. We went to O3 And we gave O3 our intent. We said, this is what we're trying to achieve. This is the data sets we have. So what kind of visuals are best visualized for the intent we have here? I said, okay, based off of that, your best luck, like the most thing you probably should try, is a Sankey diagram. So I'm not sure if you've heard about a Sankey diagram, but it's a way to visualize things that are going in and out of a phase. So oftentimes these are related to finances. So you can see inflows and outflows of a business. So we said, okay, great. We'll do a Sankey diagram. And it even recommended, oh, you can do this with Python as well. I was like, all right, even better. So we'll have O3 write the entirety of the script. So it wrote the entire script for us at first. So this was the initial draft of our script. Now, once it wrote the script, it rendered the visual and showed us. And the visual was pretty ugly. It was pretty bad. It was a bad starting point. And the reason being is it didn't have any weighting to the areas that were going through the chart. It was just a bunch of circles with lines attached to them. So it kind of looked like a neural network, really. And that's cool, but it's not useful for what we're trying to achieve here. So we're like, all right, well, that's a good first start. So we tried to go back and forth with O3 to get it to fix it. But the issue is we weren't using Canvas. Sometimes O3 doesn't default to Canvas unless you make it clear, and we didn't in this case. So what's going to happen is O3 is going to rewrite the entirety of the script every single time. And when doing this, it was rewriting it in ways that it was altering the image in kind of like worse and worse methods. So I said, okay, let's stop here. Let's take the original script and push that over to Cursor and have Cursor make inline edits for us so we don't have to rewrite the code every single time. So we passed this over to Cursor. And in this case, we did use 3.7 thinking. And we were using this to make inline edits. And then by doing this, we were able to do it by creating a more improved visual, and everything looked pretty. So if we take a zoom out here and we think to ourselves, okay, what happened? Well, in this case, O3 was our planner, and Cursor with 3.7 thinking ended up being our executor. So it executed the plan and made additional edits to the existing framework that was drafted by our smarter model O3. So that's the small use case. Now, let's go to our mid-sized use case. Now, for a mid-sized use case, I was creating a little Chrome extension for myself in relation to this thing right now, which is content creation. I was doing content stuff. And I was like, all right, cool. So let's create a Chrome extension that does some interesting things. And by doing this, I started building it out. And we ended up with a fugly UI. The UI wasn't pretty. I didn't like it. It looked kind of like a 1990s dashboard. It wasn't this bad, but it was pretty bad. And this isn't real. This isn't real. This is just an image I pulled from somewhere, but you get the idea. And some context here, I did have a planning phase prior, so I did have a smart model do some stuff prior, and then it pushed me into Cursor, so I started doing execution. The area where I flopped and I fell face first is I used 3.7 thinking when I shouldn't have, but I was using it. It was making great progress. I was super proud of it, but then it started not doing great and pooping the bed. And when it was doing that, it was messing up the UI. It was disconnecting. It wasn't finding the root cause as to why the UI wasn't being rendered effectively and all these things. So I went in circles. Things got worse. And I was like, all right, well, we need to take a step back and try something different. So in that case, I was like, all right, well, let's push this over to Gemini 2.5 Pro. To do this effectively, you should use a tool like Yeek or something similar to it. So this is the open source repo for Yeek. And what Yeek does is it takes the entire code base that you have, the whole folder structure, because oftentimes in a folder structure for a code repo, you have a lot of folders that are kind of like nested. So you want to flatten all of this out into a single file that's super flat and sits in a TXT. So once you flatten this out and you've put it into a TXT, then you can take that and you can shove that into 2.5 Pro or any other model outside of Cursor. Now, the reason I want to do this is I want to get rid of the system prompt that's sitting inside of Cursor because that kind of muddles with the specific things I want the model to do. So in this case, I sent it to 2.5 Pro. I said, all right, 2.5 Pro, find the root cause as to why this isn't being rendered effectively as it should in the front end. Figure out the root cause. So I found the root cause and I was like, perfect. Thank you so much, 2.5 Pro. So once you found this, what I want you to do is I want you to write out a series of prompts. And each one of these prompts will be fed to another AI engineer to then implement the fix you've come to based off of the root cause you found. Now, two constraints I give 2.5 Pro in writing these prompts. First off, the prompt should be big enough for us to make meaningful progress after each iteration. But the second one is to not be too big to overwhelm the AI engineer when they're implementing this. So it takes that into consideration and it writes out all the prompts for us. Once it's done this, we're then going to pass all of these super detailed and thorough prompts into Cursor to implement the fix. And in that case, I used 4.1 GPT, and it did a beautiful job because it followed the instructions, it called the tools effectively, and everything worked as expected. And in the end, we had ourselves a not so fugly UI. Now, one thing I probably should have mentioned previously is when I say tool calls, what am I referring to? Well, when I'm referring to tools in the context of Cursor, there's different types of tools the AI model can use in Cursor, many different types. But the primary ones that matter most to us are its ability to insert code effectively. Now, if you're using a model that can't effectively call tools, it's going to delete a bunch of code accidentally. It's going to add a bunch of stuff that's irrelevant. It's going to move things around incorrectly. It's just going to mess up your code and it's going to make your job harder. Building the application is going to be much more difficult if the model can't call tools effectively. Also, in addition to inserting code, tools are searching the code base, searching things in the web, reading API docs. All these are the things that make our jobs much more efficient and effective if the model can actually call those tools in a reliable fashion. So by doing this, by using 4.1, we saved the day by having plans from 2.5. So again, we zoom out here. Let's zoom out a bit here. We initially had our plan over here. Let's do a different color. Let's do blue. So here we had our plan. Here we had our execution. We then reverted back to another plan. And after we got our second plan to kind of like at mid build, we then had another executor finish off this second plan after our first plan. So we had P1, P2, E1, E2. And we walked away happy. So that was a mid-size. And the last one here is large. So this specific workflow I've talked through a million times. So if you're interested in this in detail, please watch other videos because I talked about it a bunch. So I'll give you kind of a brief rundown of what this means and how it fits into the simple framework I mentioned previously. So first things first is we need to figure out a spec. And the spec is going to be a specification that explains what this application is going to be. Now, before I get into this entire flow, this process here is useful for building applications from the ground up. So if I'm building a beefy application that's quite complex, I wanted to ensure I have a series of documents that can ground my AI engineer into what it should be building at any given moment. Because if we're going to take a long journey together, we're going to often get lost in the trees through the forest. So I need to have a series of documents that is a map for us to follow. So we're building stuff in the details so we can then ground ourselves and pull ourselves back out to then know which way direction we're going. That's kind of the premise of these documents. So for our spec, to get our spec, we're going to use, again, like I said, we're going to use a reasoning model, but this one is going to be a fast reasoning model. And the fast reasoning model is going to interview us. And that's why it needs to be fast, because we don't want to sit around and wait for the AI to respond to us. Interview. That was a horrible way of spelling interview. Let's try again. All right. And to interview us, what's going to happen is it's going to ask us a subset of questions. And each question it asks one question, we give it an answer. After we've given it an answer, the next question is informed by that previous answer. We go back and forth over and over. And at the end of this, it gives us a specification. That's what pops out at the end. Now, it's important to note that you can use this for code, but you can use this for a bunch of other stuff. And I made another video that you can check out, which is about using this process of being interviewed by AI to then create a really detailed prompt that has tons of context that you can then feed into deep research. And this is how you can get more out of deep research if you have a prompt that's beefy enough for it to understand and pursue and research on. So that's the specification. Once we have the spec, we're going to feed this spec into a much smarter model to create a blueprint. And this really covers the how. So we've talked about what we're building. Now we need to talk about how we're going to build it. And in this spec, we're going to use, oftentimes for the last probably month or two, I've used 2.5 Pro mostly. But like I said, there are issues with 2.5 Pro, and I actually don't know if I've referenced this in the past because I've sadly recorded this video a million times, internet. I've not mentioned the errors, so we're going to go through the errors here. So for 2.5 Pro, I've used this most of the time for my blueprint creation, but I've started to feel not so positive towards it because there are pros and cons. And the cons are starting to outweigh the pros, sadly. So the pros, we've already mentioned, the output length for 2.5 Pro is quite long. So it is able to spit out a lot larger document that's more methodical and detailed, which is useful for our AI engineers to follow when they're executing. But the cons are it's often outdated, and that's the primary con. And this specific model has a certain checkpoint as to where it stopped being trained. And that checkpoint means that everything that it thinks about is going to be outdated when it comes to things that matter most for us, such as APIs, such as libraries associated to certain languages or tools. It could be models. All of these things, if these are outdated, it's going to make our job much more difficult down the road when we run into errors when we're building with these models and they say, oh, like, well, there's an error here because this library is outdated, or there's API has changed recently, so you're building incorrectly towards it. So we have to do kind of midstream changes and fixes to the specifications and different types of documents to ensure we're going in the right direction. So this can be an issue sometimes. It's not an issue all the time, but just be aware. And with that being said, I will start to experiment with other models, and this is supposed to be O3. My bad. So I'm starting to experiment with other models when it comes to creating the blueprint because these tend to be more up to date because their checkpoints are later. But also, Grok 3 and O3, they also research throughout the process of creating the blueprint. Gemini sadly doesn't do it, at least in AI Studio when I play with it. It might be in the Gemini app, but not the AI Studio. And when they research midstream, they're finding different documents and APIs and models that are up to date and relevant for the blueprint. So the output might be shorter. So we're going to have a shorter output, but it might be more up to date and accurate. So I may or may not revert to using these two types of options for the blueprint, O3 and Grok 3. And then finally, we have the to-do list. So once we have our blueprint finished, we then ask that smart model once more to create us a list of to-dos. And that to-dos is going to be our roadmap for our AI. So that's going to be in a markdown file that we can check off iteratively as we build. So if we zoom out here, once more, above this line here, this segment here is going to be our planning. And then everything below this, so this yellow line here, down here, this is going to be the execution phase, or the execution models. Now, if we go down here, these are the different models that we use in Cursor. Like I've said before, I mainly use certain models here. So let's go down a bit. For 4.1, this is probably, I would say, my go-to, number 1. 3.5 is my number 2. 2.5 Pro is probably 3, and 3.7 is number 4. Now, 3 and 4, like I said previously, these are mainly focused on bugs and or really large features that may be too overwhelming for the other AIs to build in one go. But most of the time, 4.1 and 3.5 do a great job at following instructions, calling tools effectively, not causing errors with the tool calling, as well as, just following instructions good. So that is the process. That's the framework I use to think through and some of the examples associated. Now, before we go, I want to end on somewhat of a concluding rant. And that concluding rant should be in Excel. That's what it should be. All right, so practitioners. All right, this is the thing that we're going to end on. That horrible written word. All right, so the reason I want to state this is that in AI is probably one of the fastest moving technologies that we humanity have ever faced or experienced, especially right now. That means that theory and benchmarks, they're all becoming outdated and they don't always apply to specific use cases. So we as practitioners can use those as approximations and guides, but if we truly want to apply these models to the optimal way that we can for our use cases, we need to get our hands dirty. We need to play with these models day in and day out. We need to take our old use cases and apply new models to them. We need to take new models and create new use cases from them. We need to do all these different things. So it's important to get your hands dirty. And if you don't want to, you can watch videos like this and you can get a simple guide and a framework to segment these models effectively. And then from that, you can build on that. And with that being said, I hope you found this educational, entertaining. You can reshare it with your friends if you enjoyed it. And if you have any comments, please leave them below to ask questions. I'll answer them in future videos. And if you'd like to work with me, I have a company called Gradient Labs. We help organizations implement AI internally to increase their productivity, save time and money, and even sometimes generate revenue. So if that's interesting to you and you'd like to work with me, below is a link to a discovery call. It's free. It's 30 minutes for us to see if there's a good fit between the two of us. With that being said, Internet, I'll see you next time.